Okay, let's move on to the last task, task 6. Okay, so in task 6, instead of using router rib to advertise the route, we use static route instead. Okay, first we disable router rib on the 3 routers. Okay, now router rib have been removed. Okay, then we create a static route. Okay, this is the static route for R1. Okay, so hope you all still remember how to create static route. Okay, just a quick explanation. Okay, IP route is a command for static route. Then you create a route to which network? Okay, over here I create a route to the 192.168.30.0 network, and this is a subnet mask for the network. Okay, let's look back at the diagram. Okay, so what we are telling the router R1 is, I'm going to create a route to go to this network, 192.168.30 network. Okay, so in order to reach this network, okay, what is my next hop IP? Okay, this is actually your next hop IP address. Okay, where should I send the packet to? Okay, so what you are telling the router is, if the router receives a packet going to the 192.168.30 network in the destination IP address, he should forward the packet to 10.1.1.3. Okay, this is one of his neighbor. Okay, so this neighbor is actually located over here. Okay, so this is the neighbor. Okay, so whenever R1 receives a packet going to 192.168.30 network, you will forward the packet to this next hop. Okay, so that's for static route. Okay, the next static route we create is IP route, a default route. Okay, so if we receive a packet that is not going to this 192.168.30, okay, so where should he send the packet to? Okay, so the gateway of last resort, or the default route, is to send it to 10.1.1.2. Okay, where is this 10.1.1.2? Okay, this is actually R2 serial 00 interface. So we create another route, which is a static route, okay, which is a gateway of last resort, okay, to R2. Okay, so that's for static route. Okay, here's a question. Can we use the exit interface instead of IP address as the destination in the static route? Okay, if you remember, okay, this part, okay, we can either put the next hop IP or we can put the exit interface. Okay. So in this case, where should be the exit interface? Okay, remember, exit interface is the interface that you will send the packet out. So you can also write in your static route command, if R1 receives a packet going to R3, okay, instead of writing the next hop IP, okay, what we will do is, we will say that this is the exit interface to send the packet out. The exit interface is serial 000 to ask the router, if I receive a packet going to the 30 network, I will exit the packet out here. But this doesn't work, okay, for frame relay in this scenario, because if you specify this as exit interface, now the router have two choices. You can either send it to R3 or R2, because this exit interface is connected to two routers via the frame relay clock. Okay, so if you use that, okay, serial 000 as an exit interface, meaning instead of writing this, sorry, instead of writing this, you put this as serial 000. Okay, the command will still work. The router will still accept this, except that now you have two choices to make. And which choice will the router do? Okay, if you test it out, the router will actually, okay, do a round robin. That means the first packet you will try going down. Okay. First packet you will actually try to go here. the second packet will send up, the third packet will go down to R3, the fourth packet will go to R2. Okay, so if you do a ping from PC1 to PC3, you actually get a reply, request timeout, reply, request timeout, reply, request timeout. So you will be successful 50% of the time, which of course is not what we want. So in this case, we cannot use exit interface. We should use next hop IP. Okay, because we have all the destination IP share the same exit interface. This exit interface is shared between R2 and R3. Then some of you may ask, in that case, we should always use the next hop IP. Why should we use the exit interface? Okay, actually, using exit interface is better than using the next hop IP. Okay, why? Because let's say if you use next hop IP, okay, then the router will need to do one more lookup to find out what is the exit interface. Okay, so for example, okay, we use a very simple example over here. Okay, this is a router connected to another router connected to this network. Then you create a static route, IP route, to go to this network. Let's say A. Okay, to go to this network. Okay, A. This is a network. This is the subnet mask. Okay, I will use my I will use the next hop IP. This will be the next hop IP. I'll put the next hop IP here. Okay. This will be the next hop IP. Okay, what this router will do is whenever he have a packet to send to network A, okay, he will look up at the routing table and find out what is the next hop IP. And then he will check to reach to this next hop IP, which exit interface should I use? So I should use this exit interface. So there will be two lookup in order for the router to send the packet out, okay, to the next hop router. If you use exit interface, let's say this is serial 00. Instead of next hop, you use serial interface, the exit interface. Then the router only need to do one lookup. That means if the router receives a packet going to network A, you will check again the routing table, and from the routing table he knows what is the exit interface, and straight away he will send the packet out. There's no need for two lookups. So using exit interface actually make your router run much faster. Okay, instead of two lookup, it uses one lookup. But for this case where the router, the same exit interface is connected to two or more routers, then you cannot use exit interface because this exit interface can go to multiple destinations. So for this case, we will use the next hop IP. Okay, for point-to-point connection, we will use exit interface because this makes the router run faster. Okay. So similarly, you will configure the static route and the default route for R2 and for R3, okay, using similar commands. Okay, so once you configure it, you can test the connectivity. You should be able to browse the website. You should be able to ping between PC1 and PC3. Okay, finally, let's look at the challenge. The challenge asks you to remove the static mapping. I mean, instead of using static mapping, we will use dynamic DLCI mapping. Okay, so if you manage to do that, you will be able to see dynamic when you do a show frame relay map. Okay, how do you do that? Okay, basically remove the static map. Okay, how do you remove the static map? Use the no command. Okay, let's go back to the earlier command. Okay, where you configure the static map. Okay, what you need to do, basically, just do a no. Do a no and a no. Okay, to remove both the static map. Okay, do that for R1, R2, and R3. Okay, once you remove the static map, Okay, so when you remove the static map, the dynamic map will appear automatically. Okay, when you do a show frame relay map. Okay, so you probably need to wait a while, probably 5-10 seconds. You'll be able to see the dynamic map. Okay, that's all for this lab 3. See you all guys. Bye.